Hello my fellow friends, here are the solutions to exercises 16, 17, 18 and 20. First, about the biro, the ball pen. Does it fit in the box? I already explained to you that you have to go and look for the hypotenuse in a CD by using the Pythagorean theorem. Then we know that AC squared is 250. You do not have to calculate AC because of the fact that we're going to work in AGC, and there we're going to need AC squared as well. So now, Pythagorean theorem in the blue right-angled triangle, right-angled in C. And then you notice that AC squared we can replace by this 250, and that's how we get 16.58, and therefore the biro fits in the cuboid-shaped box. Exercise 17, the rhombus. We already mentioned that the rhombus has a diagonal of 16. Well, this is, of course, very important. Diagonals in a rhombus are perpendicular to one another, and they are going to bisect each other. Ze snijden elkaar midden door. Therefore, we know that AE is going to equal 8. And that's how we're going to solve this. Because if we know that AE is 8, we can simply work in, for instance, triangle ADE, and therefore look for DE. DE isn't, of course, the answer to the question because we need the length of the small diagonal, so times 2, and thus 12. For exercise 18, an isosceles triangle, trapezium. An isosceles trapezium, that means that the rising sides are of the same length, A, B, and CD. We also have many elements given, and we know that this is 4 square root 5. Now, the most important thing is this. In an isosceles trapezium, the altitudes out of B and C cut off two congruent triangles. So these triangles are each other's congruent. Yes? Okay. Because we know that, that's why we can divide the 11 minus the 5. Then we're left with 6. So 11 minus 5, we're left with 6. And 6 divided by 2 is 3. And that's how we know that this is 3 and this is 3 as well. Now, first in triangle ACE, I'm going to use the Pythagorean theorem to calculate CE, which is 4. And then if I have CE, it's very easy to work in CED because this is a 3, 4, 5 triangle, so CD is going to be 5. Final exercise. Exercise 20. The flagpole standing on top of the building. This is the flagpole, and on 8 meters height, we have certain cables attached. These attached cables go to the different vertices, hoekpunten, of the roof. So we're going to calculate all these hypotenuses. Well, EAB is a right-angled triangle over here. EAD is a right-angled triangle, and also EAC is a right-angled triangle. But you have to keep into account that we don't know AC. But to calculate AC, we are able to work in a DC, which is right-angled as well. So in this case, you're going to use the Pythagorean theorem once, twice, 3, 4 times. And when you have the different values, you can add these. Do not add all of them. We don't need AC. AC is not a cable. We're going to need DE, CE, and BE. So we're going to need DE, BE, and EC. And therefore, we get this as a result, and we're going to need at least 30 meters of cable. Make sure that you correct all these different exercises, and of course, also make sure that you understand them. If you have any questions, do not hesitate to ask. Good luck.